is of a solar cell. Let's assume that we have a solar cell. The IV characteristic of a solar cell depends on the ambient condition. What do you think the two main factors that would impact this curve will be? Can you guess? The first one, I think everybody have guessed that, is irradiance. Okay. So if you have a sunnier day, or if you have shading, if you have a gloomy day, then this would change, right? The short circuit current might be something like this. Okay, so irradiance would increase the short circuit current. It will change the open circuit voltage slightly as well. Okay, so like this is basically showing different IV characteristic for different irradiances, different radiation values from the solar from the sun. The other factor that have an impact on the IV characteristic is, can you guess? We talked about it a little bit, is temperature. So what happens when we have a higher temperature is the efficiency of the solar cell would reduce. Its IV characteristic is going to reduce as well. So it basically means that you're going to get a lower open circuit voltage. So it shifts the open circuit voltage to the left. So the irradiance would move our IV characteristic up and down. Temperature would move it right or left. And we have to be aware of these conditions, and we have to basically make some changes to the way we operate our solar panel based on the ambient conditions. Now, let's see why we need to do that. Okay. So again, let's focus on the IV characteristic of a solar panel, and I want to draw the power generated by the solar panel with respect to its voltage. Okay, with the respect to the voltage that generates. Okay, what is the formula for power? Electric power, one formula that we have is V times I, right? So what is the power here? What is the power here? This point, when you have short circuit, what's the voltage of a short circuit? It is 0. So the power is going to be 0. When you have open circuit, the current is going to be 0. So power again is going to be 0. And if we draw this, you see that at this knee point that we have here, which is basically like similar to, it's basically at this point, we would have our power picked. So this is the peak of the power voltage curve, right? And this is the point that we get the maximum power from our solar cell. So this is going to be I at which we get maximum power. This is the voltage that we get maximum power. Okay, and ideally we want to operate our solar cell at the maximum power point. Okay, or in some cases, if we are not very picky, we want to operate it in the maximum power point region, which is somewhere close to here. Okay, so there are different voltages, different currents that we can have from a solar cell, right? But there's only one optimum point. Okay, so we want to make sure that we operate at this point. Now, let's say we have a solar cell and we have a load. Does it make sense to change the voltage of the load and the current of the load, the voltage of the load to get to this maximum power point? Not really, because our load has some operating voltage. They have to operate at a certain voltage. So we cannot change the load voltage that much. Well, in some cases we can, but it's not very conventional. It's not very practical to do that. So most of the time we would have some, as part of our solar cell equipment, we would have some sort of voltage source which is of type switch mode power supplies, right? To change the voltage that comes out of our solar cell equipment so that we operate at the the voltage here, so that we operate at the maximum power point, right? So we don't want to change the load voltage that much, but we can change the voltage of the power of the solar cell so that we are operating at this point. Now this is called maximum power point, as I mentioned, and the algorithm or the method or the technique that moves us towards this point, it's called maximum power point tracking. This is tracking. So we basically want to be tracking this point and we want to operate at this point, right, which is correspondent to this knee point of our IV characteristic. Okay, so that's what Mppt is. Okay, so the next thing I want to talk about is how we can force the voltage of PV to basically regulate it so that we get the maximum power point. Okay, so there are many different algorithms, and if you look at the research every month or so, like somebody publishes a paper, another topic on maximum power point tracking. So there are different methods, but I'll just talk about some of the most common methods that are available for maximum power point tracking. Okay, and let me draw the P here as well so that we don't have to have another something like this. Okay, so